Okay, so let's go ahead and talk about section 2.1. 2.1 deals with functions. Functions are very important for the topics that we'll be discussing in this course. One way to think about a function is that simply you're putting something in and you're getting something back out. You might think about it if you're putting a problem into your calculator. You put in the question, you get exactly one answer back, then that's an example of a function. If you're getting multiple answers back, then that's not a function. If you're not getting anything back out, that's not a function. So with a function, you're putting something in and you're getting exactly one output or one thing back for your answer. Let's start by talking about what a relation means, and then we will build on that. A relation is simply a set of ordered pairs. So here's an example of a relation. You'll notice I've got the curly braces on the ends. That's my set notation. And then I've got three ordered pairs inside. If you recall, ordered pairs simply have an x coordinate. For the first coordinate is your x value. The second coordinate is your y value. And of course, these can be graphed. But with a relation, the relation is just a set of ordered pairs. A function is a special type of relation. If you have a relation where each x is being matched with exactly one y value, then you have a function. So for example, well, let me ask you with this example, would you say that this relation is a function? Does each x get matched with exactly one y value? Yes, it does. All right, so you've got x equal 2 gets matched with 3. When x is 1, it gets matched with 5. When x is 4, it gets matched with 6. So you could also think of this as saying, if you put 2 in, you get a 3 back out. If you put 1 in, you get exactly one value back out. If you put in the 4, you get exactly one value back out. All right, let's look at another example. So we're going to try to determine if a relation is a function. So what about, so this one we said yes. All right, is the relation a function? Okay, so what if we've got the set with ordered pairs 1, 5, 2, 3, and 4, 5. And let's do one more. Maybe I've got ordered pair 0, 7. Okay, so this time I've got a set of 4 ordered pairs. I'm trying to determine if each x is being matched with exactly one y value. So you'll see I've got x equal 1 gets matched with a 5. When x is 2, it's being matched with 3. When x is 4, it's being matched with 5. When x is 0, it's being matched with 7. Does each x value have exactly one y value associated with it? The answer is yes. You may be noticing that you've got a repeated y value here of a 5. So you have two x values that are being matched with the same y value. But that's not violating the definition of a function that you have in your notes. So if you read the definition of a function, it states that each x value is matched with exactly one y value. So again, unless you've got an x value that's not being matched with anything, or unless you've got an x value that's getting matched with more than one y value, you've got a function. Okay, so when x is 1, y is 5, and when x is 4, y is 5, but it's still exactly one y value associated with each x. So this one is yes, this one is a function. Okay, let's look at another one. What if we have ordered pair 2, 6, ordered pair -3, 5, ordered pair 2, 8, and ordered pair -1, 6. So again, if this is a function, each x value should be matched with exactly one y value. Think about that. Pause it for a second if you need to. Okay, so this time you're probably noticing the repeated 2. These are x values. Over here you have when x equals 2, it's being matched with y equals 6. Over here we have when x equals 2, it's being matched with 8. Okay, this time we've got the same x value 2, being matched with two different y values, and that violates the definition of a function. When x equals 2, it's going to two different things, two different y's, so this one is not a function, so this is no. Okay. So what if we have a relation that is given to us in the form of a graph, and we're asked to determine if we have a function? This is pretty easy to determine from a graph. You're just going to look at the vertical line test in your notes. Take a look. You'll see that the vertical line test states that a graph is the graph of a function if and only if no vertical line can touch the graph in more than one place. So looking at A, so just make sure you can distinguish between what exactly do I mean by the graph. The graph is the picture that's drawn inside the Cartesian coordinate plane. So we've got the x-axis and the y-axis. We're not really worried about how many times our line touches those. We're interested in the picture. So how many times can my vertical line touch this picture here that I've drawn? Well, if we look at it, over here it's not touching it at all, and that's fine. As we move in, we've got a vertical line touching the graph in two places, here and here. And of course, it doesn't really matter where I place the vertical line inside this shape. It's still touching it in more than one place. And because it's touching it in more than one place, this graph is not, this one we would say it fails the vertical line test. The graph is not a function. Okay, so you can say no, because it fails the vertical line test. All right, let's look at graph B. All right, over here, we've got a graph that the arrows on the ends are indicating that it's gradually spreading out in each direction. So as we move in from the left side, is there any way that my vertical line could ever touch, is there any way I can place this vertical line in here to make it touch my graph in more than one place at the time? No matter where I place it, it will always only touch this graph in one place. So this one passes the vertical line test. This graph is a function, so we'll say yes, it's a function. And in part C, we've got a piece in the top and a piece in the bottom. Again, we're interested in how many times a vertical line, any random vertical line, might touch the graph. Well, if I put it here, it's touching the graph here, and it's touching the graph here. That's more than one place, so this one fails the vertical line test. It is not a function. So vertical line test should be pretty easy for you to use. Please let me know if you're not grasping it. Sometimes people just don't quite see it for some reason, but then once you do see it, it's really easy. So just please let me know if you're not seeing it. I'll be happy to help you with it some more. All right, example 3, we are asked to determine whether the equation defines y as a function of x. So again, what you're asking yourself here is, does every x value get matched with exactly one y value? If you look at part A, just choose an x value that you want to play with. If you let x equal 1, then you would have the absolute value of y equals 1. What value of y would make this true? And can you think of more than one that might make this true? If y equals 1, you've got a true statement because the absolute value of 1 equals 1. Is there anything else that you could put in for y that would also give you a true statement? Yes. If y equals -1, you're going to have the absolute value of -1 equals 1, and that's also a true statement. So what does that tell us? We found that when x equals 1, we've got two y values that are going to work for this. So you've got an x value that's being matched with two y values. Would that be a function? No, it's not. That's not a function. So this one is no. If you want to think of this in terms of ordered pairs, we found that for the example, for the numbers that we chose, we got x equal 1, y equal 1, and then we got x equal 1, y equal negative 1. And so you can see that you've got an x being matched with more than one y value. Look at part B. In part B, you'll notice that the y is sitting over here all by itself, and it's defined, this basically over here is defining our y value. So in this one, you're putting numbers in for x, you're doing some operations to it, and then you're getting an answer back for y. Is there any way that you can put a value in here for x that would give you more than one y value? This time, because you're putting numbers directly in for x and your answer is giving you your y, this one's a little bit easier, in my opinion, to determine, because you can put in anything that you want for x. You're going to square it, and then you're going to subtract 3 times that original x and then add 2. Could you think of any way possible that you could get more than one answer back if you did this? This is one of those where you could just type it straight into the calculator. Would the calculator give you more than one answer? No, it won't. There's only going to be one answer associated with any x that you put into this one. So this one is a function. This is yes. As you do more of these, you'll notice that any time that you've got y solved by itself on one side of the equation, you've got y defined to be this function over here, or this relation if you want to call it that. And if you've got y already solved by itself, it's going to give you a function because you're going to put values in for x and get one answer back for y. What about part C? Part C, we've got x squared plus y squared equals 1. All right, so we'll just put a number in this time and kind of play around with it. Let's keep it as simple as possible and let x equal 0. If I put in 0 for x, I would have 0 squared plus y squared equals 1. So I want to solve the equation y squared equals 1. But we know from working with quadratic equations that this would be a really good time to use the square root property. I can take the square root of both sides of this equation, and I would get y equals, all right, and remember from the square root property, we're supposed to do plus or minus the square root of our constant. So plus or minus the square root of 1. So we're getting y equals plus or minus 1. What does that tell us? When we put in 0 for x, how many y values did we get back? We got 2 possible y values. So we've got 2 ordered pairs. We've got the ordered pair 0, 1 and the ordered pair 0, negative 1. Is that a function? No, that's not a function because you've got one x being matched with more than one y value, so not a function. Let's talk about domain and range. We can talk about, or we can discuss domain and range in terms of either a relation or a function. The domain is simply the set of all x coordinates. The range is the set of all y values. In example 4, we've got 3 little problems that we want to look at. In part A, we've got a list of ordered pairs or a relation. What is the domain of this relation? It's simply the x values. So we're just going to list the x values of negative 1, positive 3, and then here you've got positive 3 again, but there's no need to list the same one twice. So we just got negative 1 and 3. Our range would be our set of y values. So you can probably write those down pretty easily. Go ahead and do that. You should have 1, 9, and negative 9 for your range. Is this relation a function? No, because you've got, when x is 3, it gets matched with 9, and then over here you've got the same number being matched with negative 9. So you've got an x value being matched with more than one y value. This is not a function. Okay. Part B, we've got an equation this time, y equals the square root of 2x minus 1. So the domain, again, is the set of all x values. What values can I put into this for x? With this being a square root, I do have to keep in mind that we are working with strictly the real numbers here. We're not getting into the complex or the imaginary numbers. So working with the real numbers, I have to put numbers in here for x that are going to keep the inside of my radical positive. Meaning whatever is inside here, this 2x minus 1 piece has to be positive at all times. So let's go ahead and look at just that. If 2x minus 1 is positive, that means it has to be greater than or equal to 0. Solving this for x is going to give me the domain. If I add 1, well, I'll let you do that. You can solve that for x. Take a second. Pause it if you need to. Add 1 to both sides. 2x is greater than or equal to 1. Divide both sides by 2, so x is greater than or equal to 1/2. And we can give this an interval notation. If x is greater than or equal to 1/2, then we're going to say that we have the domain from 1/2 with a square bracket, comma, positive infinity with parentheses. Range, of course, is the set of all outputs or the set of all y values that we can get for this. What possible answers could we get? Y is defined to be the square root of something. And we know, what do we know about square root? Square root will always be positive or 0. It is impossible for y to equal a negative number here because the square root quantity will be positive. So our range is going to be y has to be greater than or equal to 0, which we can write in a square bracket 0, comma, infinity. And as I don't remember if my math lab is going to have you write this as an inequality or an interval notation. I suspect it's interval notation, but I'm going to go ahead and give you the inequality as well so that you can see both. For the domain, if I were to write the domain using an inequality, I would say because domain is x values, I would say x is greater than or equal to 1/2. For range, because range is y values, I would say y is greater than or equal to 0. So these answers are acceptable unless you are specifically asked to give your answer in interval notation. Okay? Is it a function? So again, to determine if this is a function, you have to decide if there is any way that you could have any x value being matched with more than one y value. Is that possible? Well, you'll notice here that you've got y already solved by itself on one side. So this means that y is defined by this side. Here you're just putting numbers in for x, doing some operations, taking the square root. All right, if you were to do this on the calculator, is it possible for you to get, what possibilities could happen here? If you put a number in that's not in the domain, like if you try to put in -7, what's going to happen? Probably going to tell you error. If you want to type that in on your calculator and do that, go ahead. It's going to give you something back that's not an answer. So, but that doesn't really count because that's a number that's not in the domain. What happens if I put numbers that are in the domain? So if I put anything from 1/2 to positive infinity, if I put that in my calculator for this problem, how many possible answers does it give me back? Just think about that for a second. Let's say if you put in 6 for x. If you put in a 6, 2 times 6 is 12, 12 minus 1 is 11, and you take the square root of 11, it's going to give you a decimal, but it's going to give you exactly one answer. It's never going to give you multiple answers. If you put in values that are in the domain, it will always give you exactly one answer back for your y. So do we have a function here? Yes, we do. Because every x that I put in that's inside my domain will always give me exactly one y value back for my answer. What about part C? What is the domain? The domain is the set of all x values. So we have x is equal to an absolute value. Similar to the last problem, just like with the square root. If you've got x equal an absolute value quantity, what does that tell you about your signs for x? X has to be positive, okay? So if x is positive, then the domain is going to be square bracket 0 to positive infinity, which is also the same thing as saying x greater than or equal to 0. What about the range? What possible values can go into this for y? Could I put in a -8 for y? Yes, I can, because y is inside the absolute value. I could put a -8 in here and then take the absolute value of -8 to get my x value. So y can be positives or negatives. So y can be anything. So we'll say it's the interval -infinity to +infinity. Or we could also say it's all real numbers. Is this one a function? X equal absolute value y. If it's a function, that means that every value that you put in for x will always give you exactly one y value back. Will that happen? Function notation is another very important topic that we want to talk about. If you can simply think of function notation as a label that you're giving to some function. Why would we need to do that? One example might be in the business world. You can imagine having to work with it's like if you've got to work with an equation for, let's say, to represent your profit, and you've got an equation to represent your revenue, and you've got an equation to represent your cost. You need labels to keep all of that straight. So you'll see different letters being used to label functions. They can be really with any letter. Here we've got function, we just called it function H. Is going to be this list of ordered pairs here. And then this one, we've got the letter F. When you see F with parentheses together like this for your label, we read this as f of x. So that means the function f evaluated at x. Try not to let that confuse you if you've not seen it before. You can simply think of this entire f of x as just another way of writing your y. It's the same thing as your y. So we've got h equals this function with a list of ordered pairs, 1, 4, 6, 0, 7, 9. And then we've got the function f of x equals the square root of x minus 3. We are asked to find the following. Okay, so each of these pieces that we're being asked to do is a computation where we're being asked to evaluate our function at some specific value of x. In part A, we're asked to evaluate function h when x equals 7. So if you go to function h, can you tell me if x equals 7, what is y? Can you tell me what that is? If x equals 7, that puts me here, y equals 9. So that's my answer, 9. In part B, we are asked to find w if h of w equals 0. Well, what is this w? This is like the x value, and h of w is like the y value. So we need to go to the h function first, go here, all right? How did I know which was which? Well, because I know that if I've got h of w, this is always the y part. The inside of the parentheses is always like the x, which is the input. So going to the h function, I've got these ordered pairs where we've got w comma f, w comma f, w comma f. Oh, I'm sorry, not w. W comma h, I'm sorry. These are h. The h is like the y value. There. So I'm asked to find w if h of w is equal to 0. So I'm going to the h function. If h of w equals 0, that means y equals 0. Or you'll think of that as your second coordinate. So find the ordered pair where the second coordinate equals 0. And that would be this one. We're asked to give the w, which is the first coordinate in that situation. So that would be like your x. So because your y value is 0, your x value is 6. So w equals 6. So it's a pretty, it's not anything fancy going on there. They've just used new labels for everything. And you've got to be able to associate, you've got to know which one is your x and which one is your y. All right. For part C, I'm asked to evaluate f of 7. So I need to find my f function, which will be here, f of x. And then if x equals 7, what is y? That's what this is asking me. If x equals 7, then I'm going to have the square root of 7 minus 3, or the square root of 4. And the square root of 4 would give me 2. So my answer is 2. Part D, I'm asked to find x if f of x equals 5. So find f of x. If f of x equals 5, then I need this piece to be 5, and I have to solve it equal to this. So I've got 5 equals the square root of x minus 3. And I have to solve this. So how would I do that? Let you think about it for a moment. Pause if you need to. Because this is a square root function and I need to get the x out of the square root function, you can accomplish that if you square both sides. If I square both sides, I'm going to have 5 squared equals, and when I square a square root, they always cancel each other out and just give me the inside. So I have 5 squared equals x minus 3. Bear with me a second while I get my borders lined up. Okay, so back here we simply squared both sides, and we've got 25 equals x minus 3. Add 3 to both sides, so 28 equals x. Okay. Example 6, we're given that f of x equals x squared minus 2, g of x equals 2x minus 3. With that information, we're asked to find, in part A, f of a. Basically, with these function problems, whatever you see inside parentheses will go into the original problem in place of your x. So this is telling me to go to the f function here and just simply replace x with the a. So that would just give me a squared minus 2. If I could simplify that, I would, but here there are no like terms that I can combine, so that's all I can do to this one. In part B, I've got f of a plus 1. So I'm going to let you think about this for a second. You need to find the f function. You want to replace the original x with the a plus 1 and then simplify that. So go ahead and try that. Pause the video. Okay, so you're going to substitute a plus 1 here for your a. You need to use parentheses, a plus 1 quantity squared minus 2. Alright, this is a binomial, so you'll expand it out. A plus 1 times a plus 1 minus 2. We need to FOIL. This is going to give us a squared plus 2a plus 1 minus 2. Combining like terms, I've got a squared plus 2a minus 1. And that's as far as I need to take it. Part C, we have to find f of x plus h minus f of x. So let's start with f of x plus h. This is telling me to go to the f function, substitute x plus h in place of all the original x's. So it's going to be parentheses x plus h, quantity squared minus 2. This is a binomial. We have to expand it out and FOIL. So that'll give me x squared plus xh plus xh or I guess we would say hx. It doesn't really matter. But you've got x times h plus h times x is going to give you 2 times hx plus h times h is h squared minus 2. Do you think I can combine anything? Can I simplify that at all? I do not have any like terms, so that's as far as I can take this part. So this is just the first part. Now I need to subtract f of x from this. So we're going to do f of x plus h minus f of x equals, and I'm going to have what I just got, this x squared plus 2hx plus h squared minus 2 minus f of x. And sometimes people get tangled up at this part, so make sure you're following everything that I've done. I started out simply by finding the f of x plus h. So that was the first step. Now I'm just substituting my result back into what I was given. So putting all this back in here, and then we're going to subtract this x plus h, this x squared minus 2. Because I'm subtracting two terms, guess what I need to use? I need parentheses. Okay, so if you need to, pause the video, make sure you're following what I've done. Okay, so this is our f of x plus h that we got from the first part, minus the original f of x piece. Now we need to distribute the negative. We'll have minus x squared plus 2. Now, hopefully we can simplify a little bit more. I know that I can eliminate the 2's, the negative 2 and the positive 2, they cancel each other out. And then we've also got the positive x squared and the negative x squared we can cancel out. So we are left with just 2hx plus h squared. So please don't write this one off as being too hard because it's important. It's building up to another concept that we'll be working with in a few minutes. So next we want to talk about average rate of change. This is very similar to when you were working with slope, when you were working with equations of lines in Algebra 1, Algebra 2. The only difference with average rate of change is that this does not necessarily have to only apply to a straight line. It can be extended to a curve as well. As far as finding average rate of change, we're getting ready to look at an example. As we're reading through it, we want to be thinking about how we can take the information that we've been given and set up a set of ordered pairs. Once we have a set of ordered pairs, then we can find change in y over change in x like you would have when you were finding slope. So let's read the problem together. We've got the population of California was 29.8 million in 1990 and 33.9 million in 2000. What was the average rate of change of the population over that time interval? So how can we write this information as two ordered pairs? You have years and you have population. Which one of those do you think would be like the x value or like the input? We can also think of this as the independent variable. The year will determine the population. So we want to let x represent the number of, we want to let x represent the year. So we'll let x equal the year. Y will be the population in millions. So read the problem again and try to set up two ordered pairs from the information given and based on what we've just discussed. So I will let you pause the video and think about that. Okay, so your two ordered pairs, you should have the year 1990 as an x. The population in that year is 29.8 million. So we defined y to be in millions, so we'll just use 29.8 for our y variable. Our second order pair is the year 2000 for the x, and the population in 2000 is 33.9 million. With these two ordered pairs, we need to find change in y over change in x. So we want to do delta y over delta x. This is exactly like the slope formula. You're going to subtract the y values. So I'm going to do 33.9 minus 29.8. Over 2000 minus 1990. I will let you calculate that, so pause the video again. If you've done your calculations correctly, you should have an average rate of change of 0.41 million people per year. Sorry, that's probably, I don't know if you can see that or not. That was 0.41 million people per year. So with the example that we just did using average rate of change, we were still working with a linear model. If we want to extend that to a curve, we're going to want to extend our concept of the average rate of change. If we're still thinking of this in terms of change in y over change in x. If we let h, we're just going to substitute our change in x with the letter h. So just making that substitution, and we're also going to want to leave the xy notation and go to the function notation. So if we replace the y's from basically our slope formula with function notation f of x, it brings us to these two ordered pairs. This is what's been graphed in your notes in the figure that I've drawn for you. It can also be found in the textbook. But essentially, we've got x, and then our y becomes f of x for the first point, and then we've got x plus h for the x, for the second x coordinate, f of x plus h. So that's like the x value, that's like the y value. We're going to make this substitution into the average rate of change, and that's going to give us a new formula, essentially, called the difference quotient. The difference quotient is very important for pre-calculus concepts. So we're going to look at some examples of how the difference quotient works. So example 8 part A, we're asked to calculate the difference quotient for the function j of x equal 3x plus 2. So this is like our almost like a formula that you've got to follow. You're going to start by finding f of x plus h. Of course, in this example, your f is like your j is like your f. So this is the j function. So we need to find j of x plus h, and then we can subtract j of x, and then we'll divide the whole thing by h. Again, remember h was just another way of expressing our change in x. But we'll divide everything by h and see what happens. So go ahead and let's do j of x plus h first. So you just need to go to your original function, substitute x with x plus h. That's going to give us 3 times x plus h plus 2, 3x plus 3h plus 2. Then the formula tells me to now subtract the original function from what I just got. So j of x plus h minus j of x will give me the part that I just found, 3x plus 3h plus 2 minus the original j function, which needs to go in parentheses, 3x plus 2. We can simplify this. Pause the video at this point, just make sure that if you need to make sure you're following so far. That's the nice thing about the videos, is you can pause me and you can go back and listen to what I just said, rather than having to just listen to me keep right on going. So always pause the video and go back and listen again if you need to. So go ahead and distribute, combine like terms. 3x plus 3h plus 2 minus 3x minus 2. And you can simplify this as far as possible at this point. 3x and 3x, that's gone. The 2's cancel out. The only thing that's left is 3h. Are we finished? No. The difference quotient told us to find f of x plus h minus f of x. That's all we've done. We've just done the numerator so far. Now we need to divide what we just found by h. If you want to put it all on one big problem from the start, that's fine, but I mean that's a matter of choice. That's up to you. So now dividing this by h. So now we can say that we've got j of x plus h minus j of x all over h equals, this is the numerator, 3h, divide by h, the h's cancel, and all that work gives us 3. That's one thing that you might find frustrating about these problems, is you have to do all these steps and you turn out with a little answer sometimes of just a single number. Sometimes, not every time. Okay? Let's look at part B. Okay, for part B, same type of problem. We're going to find the difference quotient. At least this time our function is an f instead of a j. That's nice. We've got f of x equals x squared minus 2x. So let's find f of x plus h. That's going to be parentheses x plus h quantity squared minus 2 parentheses x plus h. I'm going to expand this out. X plus h times x plus h minus 2x minus 2h. I have to FOIL, so that's going to give me x squared plus xh plus hx is going to be 2hx plus h squared minus 2x minus 2h. Normally you're not going to be able to simplify anything after you do this part. So we've got the f of x plus h. It usually will give you a long list of terms that cannot be combined yet. Now we're going to subtract the original function from what we just found. So now f of x plus h minus f of x gives me what we just did. Minus the original function x squared minus 2x. So we've got x squared plus 2hx plus h squared minus 2x minus 2h minus x squared plus 2x. At this step, you'll probably be able to eliminate a little bit, or maybe cross out some like terms. What can I eliminate here? I can see I've got x squared minus x squared, so I can cancel that out. And you've also got negative 2x and a positive 2x, so they're gone. So I have 2hx plus h squared minus 2h. And then the only thing I have left to do at this point, do you know? Before I tell you, think about it if you need to for a second. I now need to divide what I just found by h, and I'll be finished. So the entire thing, f of x plus h minus f of x all over h equals what we just did, 2hx plus h squared minus 2h all over h. All right. At this point, you can usually cancel out quite a bit, so just be careful though. If you want to think of this as breaking up into 3 separate terms and dividing by h, you can do that. Or you can think of this as factoring an h out of the top. Either way you look at it, you've got, let's go ahead and factor the h out of the top. So that leaves, I can say h parentheses 2x plus h minus 2 over h. And once I've factored my h out, that gives me 1. So I'm left with 2x plus h minus 2 for my answer. These problems are not difficult, but they are very long, and you've got a lot to keep up with, so you are going to need to make sure you find plenty of time to practice these. 2x plus h minus 2 was my answer on that one.